try that again. Typing up descriptions for a for an update saying I'm streaming, and I managed to accidentally type in the description video 2. So let's go ahead and modify that. There we go. All right, now we're streaming, and it looks like even Twitch knows we're streaming. So what I've done is I've just updated to the most recent version of Unity. And I'm going to tell the world that I'm streaming now. So, streaming game dev over at this address. Gonna do update stuff and junk. Stuff and garbage. No, literal garbage. Floating in space. There we go, and we'll just go ahead and post a similar thing over here, and then go somewhere that's not going to cause us a strange RAM load that nobody needs. There we go. So, new version of Unity. Snooky says, new stream, who dis? Hi, what's up with the off schedule? Is it off schedule? It's Thursday. Is it Thursday? I think I missed a day. How did that happen? Huh. I thought it was Wednesday. I have been sick, and apparently at some point I missed a day and didn't realize it. That explains how I didn't manage to get my garbage out on time. Great. Well, anyhow, I'm doing an off-schedule stream. Sorry for missing Wednesday's stream. I didn't realize it was Wednesday. So this is the stream. We're going to be working on the new version of Unity today, and that means that I have to check and make sure that everything still works. The new version of Unity has a couple of major improvements, including a all-in-one gizmo for adjusting positions, and some slightly refined ways to do GPU instancing, which is the secret of this project, so hopefully that will help. On the downside, I have no idea whether or not things are compatible or how it works. This is the first time I've hit play. I feel actually really bad now because I could have streamed yesterday. I just didn't think it was Wednesday. Wow, I was way sicker than I thought I was. All right, so here we are in the game world. I can already see that things are different. This is not quite how it looked before. I might have a couple of shader bugs that I might have to fix, or GPU instancing bugs, but we'll work it out. It doesn't look too bad. It looks basically the same. Obviously, I have hidden or deleted a lot of the stuff that was causing frame drops, but today what we're going to do is tackle those things that were causing frame drops and cause them to cause fewer frame drops. And that means we're going to be converting over all of our physical paneling into virtual GPU instanced meshes. There is no physical paneling in this scene because I have it turned off. I'll be turning it back on in a moment. But first, I just want to get a feel for whether or not Unity has been glitching out at all. It looks like everything worked. And the wonderful plugin I'm using for the lighting, everything worked except for, well, but that doesn't count. That's me just putting shit in the wrong place. That HX lighting I'm using for the engines was updated and seems to work great, so hurrah. I still have a hard time believing it's Thursday. That's amazing. It's been a long time since I've just lost a day. I even went to work. I'm pretty sure I went to work on all of those days, and I was just so out of it that I didn't realize what day it was. That's pretty funny. All right, so let's turn the paneling back on, which I do by actually editing the paneling script because I pretty much deleted it. I guess the easiest way to hunt it down, I don't remember what it's called off the top of my head, but it's these red icons here. So it's one of these guys. There it is. Here it is, Panel Depositor. And all I did was actually comment out the code here. We'll just uncomment out the code, and it'll all go right back up to working, at which point the scene will slow down to like 20 frames, because there are literally thousands of panels in this scene. The whole point was to push it past the breaking limit and let it break. Doot. Let that recompile. I don't think we're going to see any... Oh, by the way, if you cannot hear the clanking sound, let me know. Or if you can hear it too loudly, let me know. It should sound kind of like popcorn at the moment because I need to do a little bit of work on how it should sound. I don't have any idea how it should sound. I just put in an effect for the sake of having an effect. So here you can see this is obviously just random stuff placed arbitrarily, but you can see what the panels actually look like. And they add a lot to the feel of these debris. So having them actually function is a good thing, good call. But we used to be at 70 frames a second, and now we're at 30, so they have a really, really heavy load on our system. That's not a load we can bear. We're going to be changing them so that they use the same kind of rendering as the smaller pieces of debris, and that should bring our frames right back up to 60. Snooky says that it does sound like popcorn. Yeah, if you have any idea how it should sound, shoot me over like a link to a YouTube video or something. I have a very bad audio visualization. I can't really imagine how it should sound, so I just kind of toss sound effects at it. And obviously sounding like popcorn is not a great, not exactly what I want. All right. So what we have here in the panel depositor is a physical set of prefabs that get tossed into the world. Here they are, transform panel variants. What we're going to want to do is switch those out for a set of meshes instead. And then the meshes will be meshes that we draw. Now the problem with this is that each of these sets is not very many. It's only a couple, maybe 50 panels. So let me go ahead and show you what I'm talking about here, because I'm kind of just keep the sound and say the panels are made out of popcornium. That does sound like something I would do. So let's just go over to one of these and take a quick look, and I'll explain what I'm doing to myself as much as to you. Here is the panel system that we're seeing, okay? If I press forward here, you can see the rest of the debris. The rest of the debris don't exist in the game. They are faked, but they are faked in a way that gives them a full realization. Everything's rendered correctly. There's physics bounce and stuff like that as well. But these panels are actual game objects, these giant ones, and that's really slowing down the scene. So what I need to do is take all of these panels and turn them into virtual panels. But for the high volume debris that I've got out here, this is like 15,000 particles, 15,000 meshes, that is. And that has a lot of optimization built into it as to level of detail optimizations and stuff to keep from rendering them when you don't need to render them. And that means that there's a lot of features there that don't make any sense if you're using less than 1,000 meshes. And if I look at all of the meshes, all of the panels in this entire object, all of them combined are definitely less than 1,000. It's probably about 200. Each of the individual units is probably about 30. We can actually test that. Here is one unit, and we'll just highlight them. How many? That's more than 30. That's. Does it tell me how many I've got selected? It does not tell me how many things I have selected. Well, isn't that just great? I can't believe it doesn't say you have n selected objects. I thought it would. Well, does it tell me how many children are inside this? No? Okay. Well, it's a lot. It's more meshes than I expected. So most of those meshes are up here at the base. These here are tightly connected to the underlying framework mesh that I've got here, the square framework. So basically, the panels over here are attached to the square framework pretty tightly. And then as they go out, they start to drift away. And this is important because there are basically three kinds of collision worries that we've got here. And if I optimize this so that each of these sets is combined for the entire object, I can get away with not testing physics against all of them and only testing physics against the ones that are currently in your locale. So these here at the tightly fitted to the base, these only need to be tested if your ship is actually in this area. Otherwise, they can be ignored. They can be rendered or not rendered as necessary, but I don't have to test for physics. Whereas out here on the edge, this is a much, much wider area with a lot of space filled by these floating debris. But there aren't actually very many pieces of debris in that space. So I can test for physics just on the floating debris while you're near the floating debris. And then that will be fewer tests than back here. These are, if anything, even more panels than are floating out there, and I won't have to test them. So we can split this up into the same three groupings that we see. But in order to do that, I've got to have some kind of parental unit that can be assigned these various meshes. So we're going to need to create that. And it's going to be very similar to something we've already created, which I don't think anybody here normally watches me, except for Supafcan showed up. So my guess is that you're not familiar with what I've created before, and you have no idea what I'm talking about. Well, even if you have been watching, probably still have no idea what I'm talking about. So what we're going to want to do is go over here into this and take a look at graphics. Here it is. So we've got a couple of these debris instanced. This is obsolete, actually. I can actually delete that. So let's go ahead and delete that before it gets in our way. There we are. So draw instanced base is what we descend from. And draw instanced simple is something that just draws a sphere of garbage around our base. So if we take a look at draw instanced base, and here's debris scattered, which also descends from draw instanced base. And that's what we're using for the dense debris fields. So the dense small particles. So if we take a look here, we have a particle amount, and we have in here the spawn. And in this spawn, what we do is we collect, we just arbitrarily assign how many particles we want. And then we have a fine physical base and stuff like that as well. What we're going to want to do is have the panel depositor. Instead of creating new game objects, we needed to deposit those panels with something very similar to this. So we're going to descend from draw instance base, and we're going to have it do some more logic. Now, the problem with draw instanced base is that I designed it with the idea that it is responsible for filling out the object list. So it is responsible for deciding how many objects are in it and stuff like that. And that means that we've got to be careful when we fill it with new objects. We've got to be careful about exactly what we're doing, because it's not really built to do what I want it to do. Good news is I built it, and I can rebuild it. So what it does is it waits until it has a spawn call, and then when I tell it to have the spawn call, it actually checks to see what things are inside it. So here you can see spawning happens in start. What we're going to do is we're going to have a public bool spawn on start equals true, and then down here we're only going to play this if it is ready. So if spawn on start, spawn. So the other problem here is that these are intended to hold hundreds of thousands of objects. They have LODs built in and stuff like that. But if we have less than 1,000, then there's no reason to LOD these things. So what we're going to want to do is have another bool for public bool LODify. I think all of that is valid, yeah. So down here, what we do this LOD is equal blah, 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 blah. We're not going to bother to not calculate that. The amount of time it takes to calculate that is irrelevant. But what we're going to do down here in update is we're not going to do any LOD work if we're not LODing. So let's take a look here. This is what happens, okay? We have an LOD range, and we draw a certain percentage of the small high density objects, and then another percentage of the larger low LOD objects. And what we can do is we can make this something that only fires based on whether or not we are doing LODs. So let's just check this here. This is delta range material property block. There we are. We'll just go ahead and put in a couple of new functions here. Void LOD draw. And then we'll duplicate this whole thing for a non-LOD draw. And then down here we'll say if LOD draw, sorry, what did I call the variable? If LOD phi. LOD draw. Apparently it hasn't loaded into autocomplete yet, else no LOD draw. So basically we check and make sure that we are on camera and then we draw with the LODs. That should be fine. All we really need to do now is create a new draw instance to base and have all of the panel depositors search for it and use it. So we're going to go and select this floating debris guide. It happens to be the one that's most closely linked to the prefab I'm using. We're going to go ahead and move it so that it is just at 0, 0, 0, 0, 0, 0, 0, just for the sake of being able to fuss with it without accidentally overriding our default positioning. And what we're going to need is to put a new script here on our core object. The funny thing is, I don't think we need to code it. I think that that coding I just did is enough. I think that's all it needed to do. So we're going to go and drop a draw instance to base right here and tell it that it doesn't spawn on start and it's not an LOD. This mesh here is the problem. The overall setup that we have, okay, it looks like I do have to descend from it because we are using, I think, 4 different meshes. So we're going to need to have a draw instance multi-mesh. That's just the way it's going to have to be. We'll pop that up. So what we're going to need to do here is create a dictionary of meshes. How do I want to do this? So basically, we need to have draw instanced for every mesh. Don't need this guy. The way that the draw instance base works is down here with the draw calls. It actually tells you what it's drawing. In fact, this is a little bit too aggressive in comparison to what it needs to be, just because the new update makes half of this stuff irrelevant. But here is where I start to pass in the mesh, see? So what I've got to do is I've got to pass in only the elements that are associated with a given mesh, which means I have to be able to take in a much more complicated array of elements to the point where a draw instanced base might not even be the right thing to have. It's quite different. But I think it's probably still the best bet. The key here is that we're going to want to have these be virtual so that I can override them. I can't believe it's Thursday. I feel really silly. Well, it happens. So, this is going to descend from the same draw instance to base, but it's going to have a lot of extra features. So right now what we have with the draw instanced base is a single mesh, which is stored here, and a single, excuse me, and a single materials and a single set of position, rotation, scale, and a single matrix list of objects. What we're going to want to do is try and figure out the best way to handle this. Fundamentally, what we're doing is we are actually creating a version of this that is, you know, half a dozen different sets of these. And that's not really... Well, what we can do is we can have the fill out object list work, but the problem is that the arrays are arrays. And that means that every time we add to them, if we are adding in a new object, we're going to have to redefine the array. And also, we're going to have to keep track of what sections of the array belong to which meshes. So in order to do that, there is a little bit of groundwork that needs to get laid, and that is a little bit of an annoyance. I'm trying to think about the best way to do this because it's just like boilerplate, huge amounts of boilerplate. But I guess there's nothing around it. Well, what we'll do is we'll create a new kind of struct that is just for our own little purposes here. Public struct instanced mesh set. And then we'll do public mesh, and then we're actually going to put this in the draw instance to base. There's no reason for it to be out here. It's obviously going to be serializable, although that doesn't have to be. There's no reason for it to be serializable because you're never going to want to serialize this, but that's okay. We'll let it be serializable because there's no reason not to. So we're going to want these. And these go inside of here. Now, right now, these are arrays. I could change them so that they are lists instead, in which case adding to them would be quite fast, and I could always export to arrays. But the issue is that lists are slow in comparison to arrays. They're not noticeably slower most of the time, but when you're doing tens of thousands of operations, yeah, I don't think I want to slow them down. So what I may do is I may just initially create 1,000 for each, and then increase them as need be. But first what we've got to do is rewrite this draw instanced base to use the instanced mesh set instead. And that's going to be a valuable part of what we're trying to do here. So we're going to go and create a public instanced mesh set, mesh set. And then all of these we can get just hidden away. And what we'll do is we'll just use the mesh set. And that will be all we really need. So here you can see that we're calculating bounds based on pause. What we're going to need to do is just use that mesh set to calculate out instead. There are some problems with this. The calculate bounds position is a set of vector 3s, which works fine, except for we may have an arbitrary number of these sets. So that's not too bad because I can always just combine the bounds. But for now, we're going to just go ahead and type in the most basic thing to get it working, and then later on we will get it to be a bit more adaptable. So basically, we're just going to go through here and change all of these from being on the object to being in a struct on the object. And then later on, what we'll do is we will change it to being an arbitrary number of them. But first, I want to make sure it works. So there's still a couple of things that aren't quite right. And one of them is that when we try and work out... Okay, so I've been thinking, and this needs to be a class. Because we're going to want to convert the objs over into it as well. There's just no getting around it. But first we're going to go ahead and see whether or not this conversion works. Nope, it does not. So we're going to pop on back and see where we've missed them here. Mesh set, mesh set, mesh set. You know what? I just realized I can just undo everything I've done. Don't you just love it when you're watching a streamer and they simply get everything wrong? We're going to want to put the instance mesh set into its own file. It's not a mono behavior, it's a nothing. And then we'll just grab this from here, drop it in here. And then we're going to want to just move most of these functions over because there's not really any reason for them to be on a mono behavior. And if we move them over, I can go ahead and duplicate them as many times as I want and use the same basic functionality each time. So this should be fine. Except that there are some other things that I probably want to put into our setup here, including all of these. So we'll just move this guy down to here, and then these three are also on our mesh set. Refactoring. This is definitely the most fun you'll have all day. So all of these things that we've got here are things that should be on our new class mostly. So these, they go on our new class. So the problem with these is, of course, that why are they highlighted in red? What's wrong with them? It's not valid for this object? Oh. There we go. Most of these are correct, but some of these are not. These here, I think we can both pull them over into the new system. But you can see how some of these are a little bit less adaptable. It doesn't know what shadow range it's working with or what camera it's working with. So those are things which I guess we can store here. It seems like we're storing an awful lot on the instance mesh set if we do that, though. So it might be better to somehow pass them along by sending the draw instanced base over with them. So we'll put in that. Well, we don't even need to do it like that. We can just have them pass. So LOD draw instanced base parent, and then we can just say parent dot for all of these. And then there are some physics involved here with this push and this move object and this update object, all of these. We might as well just grab all of those and put them over here in force, because there's no reason not to. And I believe that that might just flat out work, except that there's a couple of details here that aren't quite right. So we've got this mesh set, so we'll just put that in here. And then we're going to want this mesh set that update objects, mesh set that visible in camera. To be honest, this probably should be on the mesh set. Public, and then again we want to pass the parent in, which is draw instanced base. And we'll just grab that and we'll move it up to where it should be at the top. Right here is good. Excuse me. So there we go. What we have here is a set where we have completely moved all of the functionality over into the instance mesh set. So There we go. There's a kind of mixing going on here where some of the stuff is clearly stretching across to grab things that it really shouldn't grab from another class. But we'll go ahead and just polish this up a little bit. This needs to get changed so that it is instead just a mesh set dot update, and then this. And then in here, when we're passing in the update, we actually need to pass in the parent here. And then we'll go back over here and no region for this end region. I forgot to end the region here, and I forgot to delete the end region from in here. That's fine. Those are relatively minor issues. Okay, so it looks like it's marked as overriding. Come on, there we are. Okay, so now we're getting into the situation where the rest of our setups are a little bit different, and that is going to cause us some issues. So right now we've got the situation where we have told it to spawn, and the spawning is in here, right? So what we're going to need to do is not do that. Fill out object list is something that happens after we spawn. So we're going to need to have our draw instance base to have a spawn, but it just doesn't do very much. So public virtual void spawn. Spawn. All right, so what we need to have this do is create the instance meshes that we might need. So when we take a look at our debris scattered, this here will need to actually set the mesh set position, rotation, scale, and fill that crap out. I think that this is all fine. Not sure what this is. Oh, that's for the spawn. Yeah, that's fine. That's fine too. It's all good. It's all good. So, what sort of errors do we have left? The great thing about solving errors is that sometimes when you solve an error, 800 new errors pop up. So here is where we're in the draw instance simple. And this is one we don't even use, but I guess there's no reason not to fix it, right? It could be useful later on. It uses all the stuff that we're using. It's just a matter of adapting it slightly. So here we've got the situation where draw instance base is using debris and camera proximity. This debris and camera proximity stuff was something I was trying to do, and it's not worth doing, at least not in this way. So we'll just delete it. And then here in push, we need to do a mesh set.bounce core, draw instance base, and then we're going to want to do mesh set.bounce core.contains and mesh set.push. We'll have to really adapt that in a minute. But since it does spherical collisions, we're obviously going to have to change it anyway. Draw instance cache planes cannot be accessed with an instance reference. Qualify it with a type name instead. So this needs to be draw instance base. So the only thing we've really got a problem with is the DirectX 9 system that nobody uses anymore and just wasn't removed. So that's just an error nobody cares about. It's not going to matter. The other errors are all Unity. So here we have a couple of problems. There's no camera attached to DebrisCaster 2, but a game is trying to access it. All right, so The instance mesh set is trying to get the component on the camera, get the component camera on the transform position? That's strange. I'm not sure why I did it like that, considering that the parent should have a camera. See, right there, new static. So we're going to go ahead and make that public. And we're just going to go ahead and use that. I don't know why we would have anything else. But of course, we need to make sure that we set that camera. So, no, that's done here in start. So we'll just do that in awake instead of in start. All right. Figured it out now? All right, so we still have a couple of problems. First problem is that we are inside of this object, but we should be able to back up. Come on. Oh, we're actually trapped inside. That's fine. So the other thing is we've got this similar, exactly identical issue here. We're going to want to fix this as well. So we're doing this parent.get component. And I don't have any idea why I thought that was a good idea, but instead we're going to just use draw instanced base.camera. There it is. Let's move this floating debris just a little bit because it's actually like on top of us right now, and that might be a little bit much. So we still have an error, which we'll track in a minute here. You can see that the particle system is just not rendering at all, and obviously that is a problem. I have a feeling it's linked to whatever this error is, and we're going to want this to work. Object reference not set to an instance of an object. Instance mesh set no loader draw. Why is no loader draw being called? Everything should have LODs right now. Well, even if that's still something we want to have happen, so object reference not set to an instance of an object on 151. Could be max objects, could be range value, could be LOD objects. What part of that isn't set to a value? Well, first off, let's go ahead and just delete it. And the reason we want to delete it is simply because it's just a flat copy of another function right now. We don't have to worry about it. We'll just have it do the load draw in both cases. However, we're going to get the same issue. It's going to be the same thing. So we're going to want to just do a console or debug.log lot objects. I'm presuming what happened is that we are not actually initialized. I'm presuming there is something here that is not set up to properly initialize on load. And my bet is it's this guy in the front. It's this guy here. We'll go ahead and remove him. But that shouldn't have crashed everybody. It's well, we're no longer getting the error, but we do have some interesting problems. What's this error about? This warning. So I believe yeah, okay, so that's the hopelessly obsolete one. We'll just go ahead and delete that. We've got it saved in another scene just in case. So this matrix 4x4 is fine now. We can just delete that. We're also going to want to have this check and make sure that we have something before we bother to try and update. So if obj dot count equals 0, then return. That way we won't have any problems with that anymore. But we're still not getting any sort of actual rendering happening here. And that's obviously a problem. We're supposed to have particles everywhere. And we don't have any particles. So there's clearly something wrong with our rendering engine because it's no longer trying to render the particles that are being created. And there are a couple of possibilities. One is that it might not have... it might not be filling up the list. Another is that it might not be rendering them properly due to camera problems, stuff like that. So what we're going to want to do here is just take a quick look. Debug.log filled out object list with obj.count thousands. So the first thing we're going to want to do is turn off all of this stuff. So we'll just select it all and then turn it off. The problem is that I've selected it in a way that is bad, so we're gonna just fix this here. Off. Thank you. That way we won't get a whole bunch of messages, just a couple. 5,000s and 3,000s, that's a little bit lower than I expected, but it's okay. Still, I don't see any thousands or even any tens of objects. So, while these things are properly working, they don't seem to actually be rendering. So we're going to go ahead and see whether or not this is the problem. Rendering and visible on camera. So that's rendering false, which is correct. And now it should say true. It says true. All right. So they're trying to render, but they're not rendering. So we're going to want to go into the LOD draw here and see what's up. So it may be that this part is not quite right. So we'll go ahead and just take a quick look. Drawing 1,000 high LOD. That's not how you spell high, but what can you do? Okay, so that's not firing. We're not drawing anything. So there's definitely an issue here, and it might simply be that I need to reassign the materials. That makes a lot of sense. Yeah, that's going to be a pain in the ass, but I guess I better do it, huh? So all of these now have the wrong material because I changed it so that the material was inside. Same with the mesh. The debris casters, they all have a mesh and a material in the mesh set. And the problem is that, yeah, that's new. So we're just going to go ahead and fix that for these guys. We're going to want to finish polishing this before we do it for everybody else just because it's annoying. I think that this is what we want. No, it's got two submeshes. We have got one that's only got one submesh somewhere. I think it's called Deskish. Yeah, there it is. And then we're only going to want one piece of material, and that's going to be a... I actually don't remember what material we were using. I think it was one of the particle debris materials. That might be it. We'll go ahead and try it now. Ah, there we go. Everything's working again. So the reason that this is important is because our refactoring is now a success. Last check is whether or not we can bounce off stuff. So here we go, and oh, maybe we can't. There might be a problem with the physics. There's a problem with the physics. Nope, there's not. There might be a problem with the physics. No, there's not. It's just that the sizes are set a little bit differently than I expected. Anyway, we'll be polishing those physics up maybe next time. But not today, because what we're doing for today is switching over our buddy to using a mesh system instead. To do that, we're going to want to delete the draw instance multi-mesh that we created, because this is not going to be something we need. We're just going to go ahead and allow for multiple mesh sets. This is a pretty simple setup. Right here in our draw instance base, we allow for a single mesh set. We're just going to make that an array of mesh sets, or even a list of mesh sets. There we are. And what we can do is we can just go through each. Now, the problem, of course, is that in a lot of these, we don't have any sort of understanding of what sort of mesh set we're going to be using. So here in Debris Scattered, we're actually going to go ahead and create a mesh set a mesh set thing, right? And then we're going to override start, I guess. Hold on. I'll go ahead and make this a public virtual void start so we can override it. And then we'll just override it. Come on, wake up. Wake up. Oh, that's the instance mesh set. That's not what I want to override. I want to override this. Yeah, there we are. There we are. And then what we're going to want to do is say that mesh set equals mesh sets 0. In fact, we'll just go ahead and make this protected. There we go. And that way we will have it fill up with just the first of the mesh sets. Later on, we may tweak that so that it can spawn any number of different sets of debris. But it should work. So here we've got a problem where we're not going through each of the mesh sets. We're just going to go ahead and do that. Perfect. Any more complaints? Yes, there are loads and loads more complaints. So here's the draw instance simple again. We're just going to go ahead and say mesh sets 0. This is just a debug thing, so I don't really care if it's garbage. Any more complaints? Nope. Okay, let's take a look. So this should still work. It does not. It is now broken. Oh, that's because I didn't put any mesh sets into our new friends. Of course not. So we're going to just grab here, say that they all have one mesh set. Boom. And then that one mesh set is going to have the deskish and one material, which is going to be the particle debris. Solid. And then now it should work. So this was a lot of work to do a moderately small amount of things. But the idea here is that we're going to be able to switch over our panels to this new method very, very easily. And the key to doing that is to put just a default drawer here on our floating debris. There we go, draw instance base. Don't spawn, don't LODFI. And then what we're going to want to do is give that 0 mesh sets. And we're going to just let our objects add mesh sets based on whether or not a mesh set currently exists. So that's going to require us to edit the panel depositor. Here it is. It's got its own script. I don't think it actually descends from anything. I think it's just, yeah, floating mono behavior. So what we're going to want to do is have this deposit meshes into a deposits meshes into a parental draw instanced base. Be careful not to have multiple parent draw instanced bases if you value sanity. So we're going to want to have a protected draw instanced base parent, and then we're going to want to have a public draw instanced base parent get. If not parent, then parent equals get component in parent draw instanced base. If still not parent, debug.log error, no parent draw instanced base found for name. Return parent. There we are. So that's going to be an easy way for us to quickly figure out what sort of parent we have, and we're only going to do it once, so we're not going to continue to do it with every single frame or anything like that. We're also going to need to change out some of our other objects here. We've got panel variants and stuff like that. We're going to go ahead and leave them as is for the moment and just work around them, and then later on we will cut out the workarounds and make them just work. So for that, we're going to want to go here into spawn. So here in spawn, you can see that we set the local position, local rotation, all of this nonsense, right? What we're going to do is we're just going to go ahead and all of this stuff results in some transforms. But the problem is that the transforms are kind of arbitrary. So what we're gonna want to do is go through and actually handle all of these transforms, and we're just gonna get the values from them. Later on, like soon, we're going to want to make that into a much we're gonna cut out all the game object parts. But for now, what we're gonna want to do is turn ourselves off. Game object dot set active false. But we're also going to want to upload all of these values to our parent. So transform t for each transform t in transform.children. Transform, there it is. We're going to want to say if t equals the excluded exempt child, continue. Otherwise, add them to our parental unit. So int num equals transform.child count. If exempt child, then num minus minus. And then we're going to want to set up, well, the problem is that we actually don't know how many of these are going to be there for each of these objects. So what we're going to need to do is count them individually as to which meshes they are, which is a little bit slow, but that's fine because we're just working out whether or not this works, and then we will shortcut all this crap at the end, bring it so that it's no longer a kludge. So we're going to want to grab the mesh filter for each of these. Mesh filter f equals t.getComponent mesh filter. And then we're going to want to say that mesh m equals f.mesh, or f.shared mesh. And then we're going to want to determine how many of these there are. So dictionary mesh comma int account equals new dictionary. There we are. And we'll just go ahead and say that if count dot contains key m, then if it doesn't contain the key m, then we're going to want to add it. Else increment it. Easy enough, right? So what we're going to need to do then is we're going to need to go through all of the mesh sets on our parent and see whether or not any of them happen to match. And if they don't match, we're going to need to create a new one. But either way, we're going to have to add a certain number of objects. So over here on the instance mesh set, we're going to need a new function, because otherwise we're going to have to do all that crap like manually, and that sounds annoying. So we're going to just do public void add new array slots. And then we'll just take an int slots. And I don't know whether or not there's an easy way to do that. I don't believe so. No. So we're going to need to create new arrays and then load them in. That's not too bad. So we're going to want to have 3 new arrays, which we will call Pasa, Rota, and Scala. And these are going to be equal to new vector 3 with the length of the current position plus the new slots. And they're always going to be the same length, so I guess we'll just int length equals pos.length plus slots, and then we'll just use that. And then we're going to go through each of them and copy over the existing elements. For each, int a equals 0, a is less than old length, so pos.length. A plus plus, posa a equals pos a, rota a equals rot a, and scala a equals scale a. And then we say pos equals posa, rot equals rota, and scale equals scala. Unfortunately, they will be leaving a lot of the array for garbage collection. It's not the most fantastically efficient way to do things, but, you know, it should be okay. If it turns out that it's not okay, I'll come up with a better way to do it. But, you know, should work. Should work. So over here in our panel depositor, we're going to want to check and see whether or not a specific mesh exists. So for each specific mesh in an instance mesh set exists. Instance mesh set in our s in parent.mesh sets. If s.mesh equals, I guess we want to go through each here. So we're going to want to just keep track of all of the meshes as well. Oh, you know what we can do? We already keep track of all the meshes under the panel variants. So we'll just go through. Well, no, that's not quite true, is it? Okay, hold on. Sorry, I'm thinking to myself here. List mesh variants equals new list mesh. And then in here, what we'll do is we'll say that if it doesn't contain the key yet, we'll also want to add it to the mesh variants. Now, the reason we're going about doing it like this, wait, I guess we don't have to worry about that, do we? Normally speaking, I have to worry about modifying dictionaries as I'm using them. And that means that we need to be careful not to have a dictionary get modified. But we're not going to be modifying this dictionary, so we should be able to do it. For each key value pair mesh int kvp in count. What did I get wrong here? Oh, there's just some equals here. So the mesh is going to be if s.mesh equals kvp.key. So if we have an existing set, we're going to want to just expand the set to include our new values. So we will go ahead and int index equals kvp dot equals s dot pos dot length, and then we're going to want to say s dot add new array slots kvp dot value. This should be a capital M mesh. And then we're going to want to say for int a equals 0, a is less than I guess we'll just say less than kvp.value. Okay, so what we've done here is I have screwed up a little bit, didn't I? Oh, God damn it. In trying to do this live on camera, I didn't think about it very carefully. The instanced mesh set is going to have to be something that we can add together. I can't remember what the operator override for here it is. Handy. The operator keyword in class or struct declarations. I can't remember whether I need to use the implicit or not. Public static implicit operator plus. That's not. Is that how it works? Is it? Oh, I need to give it some arguments. Instance mesh set A. Instance mesh set B. So I'm not remembering this right. I'm clearly not remembering this right. Hold on. Let me go ahead and just do a quick search. C# operator override. Public static. I guess this is just an instance mesh set. Yeah, that should work. It's no longer red. This shouldn't be base. It should be B. So what we're going to do is we're just going to make this. I think that plus equals can be its own set, but I'm actually not sure. Is that? No, it doesn't like that at all. Okay, so I guess this is fine. What we're going to do is we're going to add in all of B into A. So a.add new array slots, b.pause.length. Int len equals a.pause.length. And then what we'll do is we'll go for int a equals 0, a is less than b.pause.length, a++. And then we'll say a.pause. Oh, sorry, I can't use a because I'm already using a, and I'm already using b. So it's going to be c. Oh, this is hacky. I might be still a little bit sick. It's fine, though. It's fine, though. So c.pause c plus len equals b.pause c. And we'll just copy that for each. That says it should be a.pause. God dang. Maybe I should stay offline until I'm fully better, but I'm sick of not doing stuff. There we are. So that should work. And then we'll just return A. Notice that I am adding to A rather than creating a new class, which is not ideal, but what I'll do is I'll just mark it. Stays is modified. So hopefully that will remind me. And then what I can do is down here in the panel depositor, I can go through and just create new instanced mesh sets. So dictionary mesh instanced mesh sets. Dic equals new dictionary blah. And it's basically the same setup, but I have to change things around a little bit. So here in transform t, if t equals exempt child continue. Otherwise, we want our mesh filter f, get component mesh filter. This is actually the same as before, I think, because we want to keep track of how many of each kind of mesh we've got, and then go back and fill them in, because otherwise we'll be redeclaring array lengths. So here what we're doing is we are defining the count for these, and then we're going to create the dictionary, which is the exact same setup, except for this time we're going to be doing it in here. So we're going to want to go in here. I have all the pieces. I just have to arrange them in my brain before I, die of stupid. So basically what we're going to want to do is create a new mesh set for each mesh. So instanced mesh set s equals new instance mesh set. And then we say s.pos equals new vector 3, and then we'll give it the length. And then we'll do the same thing for rot and that sort of stuff. We could also just tell it to add them, now that I'm thinking about it. So s.add new array slots, kvp.value. And then that will create all of the mesh sets that we need in order to do that. Of course, we have to add them to our dictionary. Dictionary.add. And then we do kvp.key, comma, s. And that will give us the dictionaries that we need. And then what we'll do is we'll go down here into the transform, and we'll go through these, and we will go ahead and keep track of the position of all of these. And the way we're going to do that is we're going to use the current count in the counting dictionary for our index. So this mesh filter mesh thing is going to be gone. We're not going to keep that forever, but for now we'll keep it. And what we'll do is we will grab the count. So int index kvp, we'll just do int index equals count mesh, but we're also going to want to say count mesh, count m minus minus. And then we're going to want to put that into the correct slot. So we're going to go ahead and say dic m dot pos a dot pos index equals t dot pos, and then we say dic m dot rotation index equals t dot rotation, and then we say dic m dot scale equals index equals t dot lossy scale. There we go. And that will add them into our important dictionary. And then finally, at the very end, for each key value pair mesh dic d in dic, we're going to want to go through the parent for each. Sorry, this is instance mesh set, isn't it? So then we say for each instance mesh set m in parent dot mesh sets, we say if m dot mesh equals kvp dot key, then m plus equals kvp. The problem is I'm not actually sure whether this is valid. It may barf due to the for each, because we're modifying an included piece, but we're not changing the list. We're just modifying the contents of one of the pieces of the list. I think that's okay. I can't remember. kvp.value. I think I could just say m plus equals kvp.value. I think that'll work. And then we're going to want to continue, not continue, but break. So hold on. Bool added equals false, and we'll say added equals true. If not added, then parent.meshsets.add kvp.value. And then we set our game object to false, because right now we're rendering way too much crap. So we're just going to let that barf and see where it's barfing, and we'll try and figure out how to fix this. So here is one place where I just typed the wrong thing. And then here it is a for each iteration, so I do have to fix that. What a pain in the butt. So we're going to do for int a equals 0, a is less than parent dot mesh sets dot count a plus plus, and then we say instance mesh set m equals parents dot mesh set a. Are we doing an a in here? No, we're fine. Okay. Okay. So let's go ahead and see what happens. Barf! Okay, so it barfed a lot. Length equals pause.length plus slots, and it says object reference not set to an instance. So presumably pause.length doesn't exist because pause doesn't exist. So if no pause, then we're just going to go ahead, or if pause equals null, then we're just going to go ahead and do it as easily as possible by saying that this is all that's needed. And then we'll just say return. You got any other problems? Clear? Okay, so that time it worked. And we've turned off the debris grids, so you can see that we no longer have any of the boxes. The question is whether or not we have the actual panels, and I don't believe we do. All I see here are the loose debris elements. So let's go ahead and turn off the debris casters so that we can see what's really going on. And then we'll investigate and see whether or not it's working. You can see it is not working. So let's take a look and see how far it got before it barfed. I mean, it got all the way through. Here you can see it's got mesh sets with the meshes. Oh, just the meshes aren't defined. I'm just an idiot. That's all the problem is. I forgot to actually set up the mesh and the material in our system. So obviously it's like, what are you doing? And that's fine. I can set that up right now. So we're going to go ahead and have this contain a material. It's got a one already, override material. Are we using the override material value? No, we aren't. We are going to. Because otherwise it will be a giant pain in the ass. So we'll just set that to be a particle debris solid, and then we'll use that for our material. Otherwise we'll have to do a separate search for the mesh renderer, and that would be a pain. So here we're going to want to do a instance mesh set m. So where do we create our mesh set? Here in here it is. So then we'll say s.mesh equals kvp.key, and then we'll say s.materials equals new material 1, s.materials 0 equals, oh, actually, can I, I think I can instantiate it like this, perhaps, with an override material. Is it going to barf? I can't ever remember the C# code, but it seems like it worked. So we're just going to go ahead and see whether or not that worked. Bam, bam, ba-bam. It didn't. So how far did it get this time? All right, so the good news is this time we've only got 3 mesh sets, which is more like what I had in mind. We got intact, dented. Well, that's strange. Well, either way, these are valid meshes, and these are valid materials. Pause, rot, and scale might be kind of long, 299, so there's 300 of those. They're marked as not visible on camera or receiving shadows, so I wonder whether or not there's something wrong with their detection. Did I remember to call? I did not. So what happened here is I forgot to tell the parental object to actually calculate all the things it needs to calculate. So it's got the mesh filters it needs, but then it doesn't ever actually calculate anything. So we've got here in awake, we have this if spawn on start, then spawn. I think we're going to keep that, but we do need this to spawn on start. And what we're going to want to have happen is we're going to want to have that have a later execution time than the object that we're using, the panel depositor. So we're going to drop the panel depositor in here up near the top. No, that's the moments recorder. That actually needs to be at the end. There's the panel depositor. And then we'll apply that. And that way, that should fire first, and then it should calculate, and we should see either a lot of errors or a functional setup. We did. Look, there's stuff. Hurrah. So, of course, the issue with this is that these large panels are rendering funky. And the reason for that is because we're currently using an LOD setup, and it's pretty clear that it's got some wonky values. But as of now, these panels are showing the correct responses. Even their collision is working okay. Now, it's obvious that we're going to need to change how these panels work at range. It looks like the default of 200 meters is really low. Is that shadow range is 200? For some reason, these guys are not responding well to a shadow range of 200. We'll go ahead and say that's a shadow range of 2000. Just because having those panels be just pitch black is very strange. Well, you know what? That didn't seem to help much, did it? My guess is that it's an LOD issue. My guess is that we are doing some very, very aggressive LOD work. So let's go into this and fix the LOD system, because right now we're not actually able to tell it to not use LODs. There's a button for it, but it doesn't do anything. So we're going to just copy this and paste it, and then we're going to make it a non-LOD. So the no LOD draw has one big difference. It doesn't give a crap about any of this. So we're just going to go ahead and delete all of these and just go through all of the blobs in the obj. So we'll just do this. This is also a good time for us to investigate the new upgrades. So previously there were only like 3 options here, and now there's a friggin' million of them. And the reason is because they need to be backwards compatible with their first option. So you see that count? That count is no longer necessary. So we're going to try to do this with no count, just to see whether or not it works. The question is, what is that second value? Submesh index. Okay, that's fine. So we're just going to save that and see whether or not that barfs. Okay, so apparently there is no setup that's exactly what I thought we were getting here. Material, and then we got matrices, that's the blob. And then we got account or properties. Material block properties, that's correct. And then we've got shadow casting mode. And then we got the receive shadow mode. So what part of this didn't work? This is what we want. So it's mesh, yes. Submesh index, yes. Material, yes. Matrices, yes. Material property block, yes. Shadow casting, yes. Shadow receiving, yes. Change this to true. So as far as I can tell, this is correct. All of these are correct. So what is it barfing about? Either it or I have confused something here, because this doesn't seem to be able to pick up on the fact that that there is a new, better value. Huh. Well, either way, that should work. We just got to go up here and switch it in. Let's go back over here to our Twitch channel. Nope, nobody said anything. It's a very peaceful day. Okay, well that didn't really help, did it? They're still very pitch black. The good news is we're not going to get any LOD popping now, because there's no LODs. The bad news is that the material we're using is actually not built for this situation. So we're going to want to change the default materials to something other than what we're using right now. Using particle debris solid, I'm going to change this over to prox hull. No, that's prox interior. I want prox hull. There we are. And we're just going to go ahead and see whether or not that looks a little bit better. Yeah, that's more like what I have in mind. Look at that. So this is fast. This is hellishly super fast. There are still some things we need to do. One of the big things we need to do is make it so that there's not a whole bunch of transforms being generated. If we actually take a look at what happens inside of these debris grid injectors, you will see that they are full of crap. There's no reason for them to be full of crap. What we should have is a setup where they don't generate transforms. They generate a list of things. And we already are doing most of that. It's just a matter of baking down all of this stuff into a couple of things. One of the things we're going to want to worry about here is these. There are 3 tiers of object. The ones that are stapled to the surface, the ones that are floating a little bit, and the ones that are floating a lot. And they have the same fundamental code. So the question is whether or not we should keep them separate or whether or not we should just duplicate. I think that duplicating might be a little bit easier, actually. But we're going to need to keep track of all of this stuff. So what we're going to do is, I think, we're going to go ahead and create 1,000 objects, or maybe just panels tall times a number. So hold on. Int max possible spawns equals, and then we're going to want panels dot length and all that jazz. So what is it? It's intact panels, damaged panels, floating panels. And then we're just going to say max passable spawns times equals the width. Intact panels wide? No, it's panels tall. There we are. With max possible spawns in place, we can actually just do it like this. What we'll do is we'll create a worst case situation, and then we will add in the just the pieces we need. And to do that, we could have a setup on our instance mesh set, which reduces the size of our arrays. So for that, we'll just grab this add new array slots and say set array slots. And what we'll want to do is have these simply be the exact same setup, but we're not going to want to go past it. So down here we'll say if slots is greater than pos.length, return, and we'll want to just add. Otherwise, we're going to want to only take the pieces that we need, and that means this works fine. And that way we'll be able to reduce the length once we're done. So that way we can just set it up once. We don't have to keep recalculating these arrays every time. It's still not perfect, but it's better. And then we're going to want to pull our dictionary here up to here. We're going to want to go through all of the possible meshes. We have this as transforms. Well, guess what? They are, in fact, meshes. And what we're going to want to do is set those meshes up as dictionary meshes here. So for each mesh m in mesh variants, mesh possible meshes, what's it called? Panel variants. There we are. So once we have this, we can create a new dictionary for each panel variant, but the panel variants are not guaranteed unique. So for each key value pair mesh, instance mesh set D and DIC, if D dot key equals M, then need new dic equals false and continue break. And then we say if need new dic, then instance mesh set instant mesh set equals new instance mesh set ims dot add or set. I can go ahead and do set or add is fine. Add new array slots, max possible spawns. Ims dot mesh equals mesh, and then ims dot. I can copy those from down here because I don't like typing that part again. So where is it? There it is. And then we add it. So go ahead and make a list here. So first create a dictionary. First create an instanced mesh set with an array large enough for any situation. The individual array elements. We can optimize it later if necessary. Now generate the panels, adding to the correct instanced mesh set with each new instance. For that, we're going to need the dictionary that counts. Count.add M0. So here, we actually set up this whole system where we go through and we find all these values. And the reason I was like, is because we have to change how this works, and we got to change it 3 times. It's not very well programmed. Some idiot programmed it. So here what we're going to take a look at is all of these are actually working fine. Here is what the problem is. When we say transform n equals panel variance, we're going to have to change this over into a mesh. And if the mesh is null, then continue. Otherwise, we're going to need to fix this. We're not going to be able to instantiate the mesh. There's no reason to do that. Instead, what we're going to want to do is calculate out all the positions without ever needing to instantiate the mesh. So for that, we're going to want to have just a floating set of vectors. So vector 3, pause, and scale, and then we'll have a vector 3 or a quaternion rot, and we'll just override those. So we don't need this. We don't need this. N local position equals. So here is where we come up with the local positions and stuff. So the problem is that these are all local. It's not too bad though. So here's our position. Here's our rotation. And then we actually do this local bounce with a set. This takes a rotation and a position, which we are not actually able to do at the moment. So we're just going to hide it for now. Bring it back later. And then that creates our position and our rotation, right? But what we need to do is also create our scale. I'm not sure we actually have a scale. So we'll just set the scale to a flat value. We can come back to it later. So our scale is going to be the same as our parent's scale. So scale equals transform.lossyscale. Maybe. So what we need to do is convert these values into the correct setup, and I think we're going to want to do that in a function. So we'll just go ahead and take these and make them into variables that are outside of our setup. Just so that we can modify them without needing to worry about it. So in order to do this, we're going to want to rename some of these here so that they're more clear. We'll take this and be an instanced, that's how you spell it, instanced mesh dictionary, instance mesh set dictionary. And then this will be instanced mesh set, instance mesh counter. There we go. And then we're going to want to have a void add instance mesh vector3 local pos vector quaternion local rot and scale global scale. And what we'll do is we'll just add them in, and we'll go ahead and say instanced mesh counter m++, but we're also going to want to make that our index. So int index equals instanced mesh counter m. And then what we're going to want to do is add to our instance mesh set dictionary. So instance mesh set IMS equals instance mesh set dictionary m. And then we want to set this up IMS index, or IMS pos.index equals, and then we need to convert the local position into a global position. And we do that by calling transform point local pos, and then we say IMS.scale index equals global scale. That one's already global. And then we have IMS dot rot index equals local rot times, and then our parent rot. There we go. That should do it, I think. So with that in mind, down here, once we've called the functions required, we can then add the values back into our system with add instance. Like so. We're going to want to do this over and over and over. Right now we are trying to figure out the best way to handle this, and I think that we're going to want to just really carefully go through and duplicate the changes, because all of these are a little bit unique, and it's really garbage. I shouldn't have programmed it like this, but it happens. It happens. And then down here for the last one, and then maybe that'll work. Okay, but then what happens is down here at the end, we've got to get rid of some of this garbage that we created specifically to do all this work, right? So the first thing we got to do is we got to chop our mesh instances to the correct length. So for int a equals, or let's see, for each key value pair mesh int. That's supposed to be a bracket. KVP in count. We're going to want to access the mesh set and change its length. So mesh set counter kvp.key.set array slots kvp.value. There we go. And then down here we can delete most of this. All of this stuff. There we are. And then we have this final bit where we move through all of our dictionaries and we add them to our parent. That part we keep. So all of these, that's all the same logic. We don't have to disable the game object anymore. We don't need a lot of the functionality that we put in before, but we're going to have some barf. Yeah. So here you can see that our debugging is barfy. So we're going to go ahead and delete that debugging. Come on. Come on. You going to recompile? So here we're getting the transform rather than the mesh. So here it says cannot convert. Oh, that's because this is supposed to be the mesh. It's supposed to be the instance mesh dictionary rather than the counter, obviously. All right. Anything else? Is that it? Hooray! Let's take a look and see whether it worked. Boom! Argument cannot be null. Perfect. Okay, so we've got a bunch of arguments cannot be null and no thing to show for it. So let's take a quick look. I just don't have any panels, but that should just result in an empty thing. It shouldn't be an argument cannot be null, parameter name key. I'm not really sure why I'm getting that exact error, but you know what? First things first, let's fill in the destroyed parts that we're going to need here. Oh, right. These are supposed to be individual meshes now, aren't they? All right. Well, let's take a look and see what actual meshes we're using from which file. Proxhull from, that's the material. Panel intact 02. They really are named panel intact. What an idiot. So these obviously have the wrong names. I don't know why I didn't fix that, but at least we know what they are. So we're just going to start to drop them in. We're going to have this. Boom. And then we're going to want a missing panel, and then another intact panel, and then a dented panel, and then another missing panel, and then a smashed panel, and then a really dented panel. I'm not 100% sure that I was using all 4 of those. I have a feeling that I left one of them out. But I can always polish it again later, no biggie. So we have this issue where an argument cannot be null, but it's not telling us where we have an argument that's null, which is kind of interesting. I have a feeling that what I'm doing is I'm trying to add a null key to the dictionary. So if we take a look at this, then what we're going to look at here is M is panel variance. So if M equals null, then continue. Not sure why it's not giving me a line number there. Yeah, that was it. Should have given me a line number, though. All right, so there you can see it works fine. This is a 100% faked set of meshes. There's no actual game objects involved. And they do respond. Now we have to fix the collider testing. Right now it's using a spherical collider against a spherical collider. We're probably going to need to change that over into a spherical collider versus a rect, but for now it'll work okay. I don't really know the best option for keeping it as fast as possible physics-wise, but I do know that this is the best option for keeping it as fast as possible rendering-wise. Right. So we're going to go ahead and just create a bunch of duplicates of this so that we can see how it works in full force. There already are a bunch of duplicates of it. If we hit apply, we should be able to turn them all back on, and they should just be correct. So let's drop this guy back into the... Let's drop him back to 0 for a second, apply him, and then move him into this mess. So, how did we do? Look at this, so much debris. And we are running at 70 frames a second now. That's substantially better than we were before. Now, the problem with this is that we no longer have the ship in the scene because I have to redo all of the prefabs with the new system because they all have the old system right now. But this looks pretty good. Yeah, I kind of like it. Kind of like it. So I'm almost done. If you got any questions, ask them. I presume that the one of you that is watching doesn't have any questions. But what we're going to do for the next couple of minutes is try and take a good GIF. So that is quite the view on its own, though, isn't it? Look at that. That is a lot of junk. So we'll just go ahead and fly through some junk here and try and get a good feel. So, is that really all the faster you can go? Oh my gosh! Crash! That wasn't very good. Let's try that again with less crashing into random crap. Neo Dragoon says, I have one. Well, feel free to ask it. I am happy to answer questions. Bum, 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 bum. Bum, 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 bum. Save. Hopefully that'll be under 15 megs. It's hard to tell. It'll take a while for it to finish rendering. I will take a sip and answer Neo Dragoon's question if he ever asks it. Presumably he's typing. It takes a while. To be honest, I could probably get away with fixing all of these. Let's go ahead and do it. Projector. All of these debris projectors have to be repaired. So we're going to want to do that. We'll just drop in the panels just like we did before. There we are. So now if we turn this back on, well, these need to all be saved. So let's save them and then we'll turn it back on and we'll see whether or not we have a fully functional space station. So blip. And then we'll just apply. 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 And then blip. So now let's turn on that ship. There it is. And let's take a drive and see how it looks. First things first, I want to move this guide. We'll just use the unified widget and then try and move it into a position where it feels fun to fly through, which I think here is probably best. Oh, I bounced. I didn't want to bounce. Bouncing makes it fail. Well, we're going to want to move this ship just a little bit anyway, because it's not exactly in the right spot. All right, so Neo Dragoon has asked a question, but I'm going to just go ahead and fly for a second before I answer it, since otherwise I'll crash. He's asked a general question about games programming, and I'm happy to answer it in a minute here. Okay, so that did not take. We're going to want to look into that later. Neo Dragoon says, if you play Majora's Mask, some characters have a schedule that goes from scene to scene. How do you do that in Unity so that it keeps track of where they are regardless of what scene the player is in? That is an excellent question. So there are two answers. The official answer is that you use something called a scriptable object. So all of these things are mono behaviors. The transform is a mono behavior, the ship damager is a mono behavior, the cargo module, the mesh filter is a mono behavior. This is all mono behaviors. Mono behaviors are things you stick on game objects. Their cousin is called a scriptable object. A scriptable object is a mono behavior that you can't stick on any objects, and they exist only down here in your project. Because they exist in the project, you can modify them, and it won't just be in one scene. So, for example, if you wanted to have, a blacksmith, you could have the blacksmith scriptable object, and then every time the blacksmith is, if you want to check and see whether the blacksmith is spawning or not, you say, scriptable object, can you tell me where the blacksmith is? And it doesn't matter what scene you're in, because the scriptable object isn't in any scenes. You can also use prefabs for this. So I've just talked about scriptable objects, but if you are feeling like you don't want to learn scriptable objects, an easy alternative is to have that blacksmith's prefab, like the thing that goes in the scene, have it store where he is, but make sure you modify the blacksmith prefab and not the instance. And that way, when it's in here, down here in your project view, it will keep track of where the blacksmith is, and you can just choose whether or not to spawn it. So, for example, I have this call large ship file. I could just access this file while it is in here in the prefab system. So let me see if I can, I have some examples of that I can show you, because that's a little bit weird. When I'm spawning stuff inside our ship, here it is. So, for example, I have these HAB modules. And these HAB modules have a whole bunch of damage variants. These damage variants are all prefabs. The data in the prefab is outside of all of the scenes. So whatever is in these prefabs, it doesn't matter what the scene is. It's still the same data. Once I put this into the game world, modifying the data in the game world won't change the prefab. But I'm allowed to modify the prefab. I'm allowed to, before even spawning these in, I'm allowed to do whatever I want. I can look through the prefab for things that are attached to it. I can change values. I can see, if I've got any kinds of exceptions and stuff like that. So you can just put values into the prefab and change those values as long as you're careful to do it to the prefab. And that will also propagate outside of scenes. Both of those are a little bit iffy because they don't save and load across different save files very well. But if this is your first time and you don't really care about that, they're both the same solution. Whether you're using scriptable objects or prefabs that don't get instantiated, those are the same. There's really very little difference between a scriptable object and a prefab that doesn't get instantiated. I'm not 100% sure that was easy to understand. If you look up scriptable objects, you'll be able to get a tutorial on the same thing. Just keep in mind that a prefab and a scriptable object are nearly the same thing. It's just a matter of one of them having a transform and several other attachable objects. But if you look up scriptable objects, it'll tell you how to do that. The other alternative is you can use an in-world universe manager. It's something I do a lot. So the in-world universe manager here might be the sun or the camera, and all you have to do is tell it that it should not get deleted when you change scenes. So you could keep track of all of your characters and stuff by having all of that data on the in-universe manager, and then when you change scenes, the in-universe manager doesn't delete itself, it stays. And that can be easily saved and loaded between saves. So that's something that is very flexible if you plan to have lots of different playthroughs with lots of different characters, lots of different save files. You just use the in-universe method and you can save and load the differences. Now the way to do that is to use the don't delete on scene load or don't delete on load, don't delete on scene change, something like those. If you look that up, you'll be able to find it pretty easily as well. So the two basic options are to use don't delete on scene change or to use scriptable objects. Here it is, don't destroy on load. This is what it's called. And I do this on DoTween, but that's all right now. I just sort of explained it off the top of my head, so not 100% sure that it was clear, especially if you're not familiar with it. I'm pretty close to the problem, so I'm way too familiar with it, and I'm not sure how clear I'm being, but look up scriptable objects and look up don't destroy on load. Those are the two alternatives, and either one will work fine for what you're doing. And I will see you on Sunday, unless I forget that it's Sunday, and in which case I'll see you some other time. I can't believe I missed a day. I must have been real sick. See ya.